Dear student, we already completed the solution unit. If you want to video, you can go to the search in our channel. That is a present. Nowadays onwards, we start the organic chemistry. The first topic, there is some basic principle and techniques. There is a simply say this. There is a GOC, General Organic Chemistry. Okay. So first of all, the organic chemistry, there is a most easy division of the chemistry because the essential of the basic fundamental, if you know whatever the question, whatever the topic, we can easily solve it. Okay, so that's why I'm saying there's a most easy topic in the division of organic chemistry from the chemistry topic. Okay, so first of all, the organic chemistry, what the study of the carbon compounds is mostly they have covered. Okay, so we need to knowledge of carbon, what kind of element and where it is a present, what is a valency, like that. We can go to one by one. There is a organic chemistry. Organic, the most studied with regarding the carbon. Okay, so we know that the carbon it presented in the p block in the periodic table, p block elements. Okay, so such a p block element, there is a non-metals. Okay, or non-metal. Okay, then next, if you know that only non-metal and non-metal between the non-metal and non-metal, the making bond are called, there is a covalent bond. We will study the chemical bonding unit for future. Okay, so in generally among the non-metal and the non-metal, that bond are the covalent. So for that reason, in the case of organic chemistry, all bond are the covalent bond because there is a mostly covered in the carbon element of carbon. Okay, so in the case of the valency is equal to 4 because the atomic number of carbon as a 6, it's electronic configuration 1s2, 2s2, 2p2. Okay, so it's for the electronic configuration. We go to the electronic splitting method. There is a 1s and there is 2s and 2p. 1s it possesses the only 2 electron, and 2s it also possesses the only 2 electron, and 2p it also is presented in the 2 electron. There is a separate way. There is a ground state. It's a ground state electronic configuration. If you go to the excitated state, there is a 1s, it is like that, and 2s 1 electron is can go to promote in that the 2p cell. Okay, so for that reason, they have the valency cell 4 unpaired electron are presented. Such a 4 unpaired electrons are making a bond. That is a making bond. What kind of bond? Yes, that is a covalent bond. So for that reason, the covalency or valency of carbon is equal to for 4. Okay. The next, the carbon, it depends on that hybridization, whether they have tetrahedral or trigonal planar or linear in shape, like that we will study. Now there is a, if we the carbon there is a valency and there is a shape and the hybridization. Okay, hybridization. So the carbon of valency if 4. Okay, so that is a 4 here, making 4 sigma bond and 0 pi bond. For that carbon, that is a hybridization, sp3 hybridization. Okay, sp3 hybridization means there is a shape as a tetrahedral shape. And similarly, there is a 3 sigma bond, 1 pi bond. If carbon, it possesses a 3 sigma bond and 1 pi bond, that is for sp2 hybridization. What? sp2 means there is a trigonal planar as a geometry. And similarly, there is a 2 sigma bond and 2 pi bond. For this here, there is a sp hybridization, that is for linear geometry. Okay, so suppose if you have doubt, there is a 4 or 3 pi bond and 1 sigma bond is like that, if any possible. Yes, it's not possible because the first formation of bond also is a sigma bond. We will study that is a chemical bonding unit because the pi bond is cannot exist as a separately. Okay, the next, the catenation property. The catenation property, the generally the carbon it has the highest. That's a catenation property, that is for carbon as a highest because there is a only in the periodic table of non-metal, the highest catenation properties of carbon is a very large number of organic compounds are given. For example, the hydrocarbons, the polymers of hydrocarbons, like etc. And that is a very important. Then we go to that the tetrahedral and the trigonal planar, and that is a linear geometry. So tetrahedral means that's a carbon, the hydrogen, 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 hydrogen. This was the tetrahedral geometry. So here one bond to another bond, that is meaning there is a bond angle 109.28 minutes. Okay, 109 degree or and 28 minutes. There is a tetrahedral bond angle. And similarly, this tetrahedral bond angle 109 degree, and it's a hybridization as a sp3 hybridization. Here the percentage of s character, that is equal to, for that is a 25 percentage s character, 25 percentage only for s character. And similarly, the bond length is equal to 1.54 Armstrong. Okay, the trigonal planar, there is a carbon or hydrogen here, carbon, hydrogen, hydrogen is there. This for the trigonal planar geometry, Here the bond angle and the bond angle is equal to 120 degree, and there is a hybridization is sp2, and there is a percentage of s character, that is a 33.33 percentage. It's a bond length that is equal to 1.34 Armstrong. Okay, the bond length that is equal to 1.34 Armstrong. And similarly, there is a linear HC triple bond CH. This is a linear relation. There is a bond angle the 180 degree. It's a hybridization, such as sp hybridization. The percentage of s character, that is a 50 percentage s character. It's a bond length that is equal to 1.20 Armstrong. Okay, now we go to that the electronegativity and etc. such point. The electronegativity, that is equal to or directly proportional of percentage of s character. Okay, so from that the electronegativity order, there is a sp is greater and then sp2 and sp3, such as there is a electronegativity order. So the percentage of s character increases, the electronegativity increases. For that electronegativity concept, we will study there is a acidity, basicity, so etc. And the types of bond, actually the sigma bond, they have orbital overlapping through the axial overlapping. Okay, there is a sigma bond. This also will study the chemical bonding unit. The sigma bond, if the orbital overlapping in the axial manner, there is a axial manner, that's called, there is a sigma bond. Okay, for example, the s orbital overlap with s orbital and p orbital and d orbital and f orbital. For that, any orbital is overlap with s orbital, that is only for the sigma bond, because the s orbital are non-directional orbital. Okay, these are the non-directional orbital. Okay, so non-directional means they have overlap with always the axial overlapping. Okay, and the p orbital and the remaining orbitals, p orbital, because only the carbon it possesses s and p orbital only are presented. The p orbital, they have making a sigma as well as a pi bond. Okay, there is a sigma bond as well as the pi bond. This sigma bond, they have axial overlapping or head to head overlapping. That's called, that's a sigma bond. This bond are generally there is a stronger bond. There is a sigma bond or the stronger bond. Okay, and the pi bond, there is a pi bond that is equal to lateral overlapping or the sidewise overlapping. For example, see, there is a orbital loop and this all another carbon of orbital loop. These two, it is a axial or there is a sidewise overlapping. That is for the pi bond. Okay, that's for the pi bond. So for that kind of chemical bonding, especially the sigma bond, in generally the bond strength, that is equal to for a sigma bond greater than the pi bond. Sigma bond is greater than the pi bond. So the reactivity, that is pi bond is greater than the sigma bond. Okay, so simply the types of the primary and secondary, how we find out. When a carbon atom is bonded to only one carbon atom, that's called primary. When the carbon atom is bonded to the only two carbons, that is for the secondary. So like that, if you see this molecule, this carbon is assumed, this carbon is only substituted this carbon, so that's why there's a primary. And this carbon is only substituted for this carbon and this carbon, so that is a tertiary. And this is a primary, and see this carbon is substituted 1 2 3 4 carbon, so that is a quaternary. And this carbon only substituted this carbon and this carbon, so there is a secondary. And this carbon, what? Yes, very good, that is a primary carbon. Okay, so this also is a most basic fundamental. Okay, we will see this organic most basic fundamental for upcoming video. If you like this video, subscribe and share your friends. Okay, like